What's happening today? We're going to go over conditional probabilities, and this is a concept that I personally learned in my AP stats class, but it comes up on the SAT, and I kind of find it crazy because unless you're in a higher level stats class, you may never learn it. Therefore, I want to go over it. Remember, I'm Zach, this is 5-Star Prep, and if you enjoy this video, go ahead and give it a like, comment, as well as subscribe down below. Let's get into it. When we talk about conditional probabilities, we're talking about the probability that something occurs given that another event occurs. And a lot of times this is introduced via the formula, the probability of A, given that vertical line there means given B, equals the probability of A and B over the probability of B. And for a lot of students first learning statistics, this formula can be overwhelming. Rather, I want you to focus on this next example and the table presented, and not worry about the formula, but what's actually going on. So let's hop into that example and see what I mean. In this example, we have a two-way table or contingency table, and it says to find the probability. You may express your answer as a fraction or a decimal rounded to the hundredth place. The following table represents dessert preferences for children at Eastern Elementary School. The table includes the gender of the students at the school as well as their favorite dessert from the three options presented in a survey. Questions 1 through 5 refer to information from the table below. And then they give us this table where we have gender as well as dessert options and then questions. The first one says, what is the probability that a student is female? So let's go ahead and start there. But before we do, I want you to make sure that you take a look at your table and you recognize that it doesn't have margins. And we want to fill out the margins for the total of the rows as well as the columns. So go ahead and grab your calculator and let's get started. First off, let's figure out how many students preferred ice cream. That's 16 plus 22, which is 38. So we're going to fill that in right here. Again, if the question does not provide margins, some questions will have margins in your table, which is very nice, but some won't, as we see here. So you want to fill those in. Then we have donuts, that's 24 plus 17 or 41. And finally, chocolate as the preferred dessert, which is 11 plus 12 or 23. So we have those filled out. Let's fill out our rows. We have females, 16 plus 24 plus 11, which is 51 students, 51 females. And then we have males, which is 22 plus 17 plus 12, or 51 as well. So we have an even number of females and males in our survey, 51 each. Then how many prefer ice cream? 38. How many donuts? 41. And how many chocolate? 23. For a grand total of 102 participants. All right. So it says, what is the probability that a student is female? Well, that's pretty straightforward. How many females did we have and how many students did we have? Well, we had 51 females, and that was out of a total of 102 students. That would simplify to 0.50 or exactly half. So we're good to go there. It would be a little complicated trying to get that answer without filling in your totals. What about 2? It says, what is the probability that a student's favorite dessert is ice cream or chocolate? All right, so here, we want to figure out how many students preferred ice cream or chocolate. Whenever you see the word or, that means we want to add up the probabilities of how many liked ice cream as well as chocolate. So here, how many students liked ice cream? Well, that is 38. How many students liked chocolate? 23. So that's my numerator, and then we're going to put it over the total number of students, which is 102. 38 and 23 is 61. So we could write this as 61 over 102, and that would be approximately 61 divided by 102, we can round that to the hundredth place as our instructions say, or 0.598, which rounds to 0.60. So around 60% of students preferred ice cream or donuts. What about 3? Question 3 here says, what is the probability that a student's favorite dessert is donuts given that they are male? So we can rewrite this if we think back to the formula P of A given B equals probability of A and B over the probability of B. That would be the probability of donuts given male. So here, whenever I see the word given, I always want to try to condense my sample size. Instead of being out of 102 students or all the students, now we're only focused on the male students. So how many male students do we have? 51, right? That's going to be our denominator. So here our denominator is 51, and our numerator is going to be how many students are male. We're only worried about this row right here. And how many of those male students liked donuts? Well, that's 17. So our answer here is 17 over 51. But if we think back to that formula, probability of A given B equals probability of A and B over the probability of B, well, the probability of A and B is that they're male and they like donuts. And that is this intersection right here, or 17. That's our numerator. And then our denominator is just the probability that they're males, or 51. So you can think about it either way, really just focusing on the table itself or taking into account the formula, but either way, either approach will work. So 3 here is 17 over 51, which when I plug that into my calculator, I get exactly 1/3, or 0.33. So 17 over 51 is approximately 0.33. Let's move on to number 4 now. Number 4 says, what is the probability that a student is female given that their favorite dessert is chocolate? So now we have the probability that they're female given chocolate. And I'll go ahead and abbreviate chocolate just like that. So now, how many people prefer chocolate? Well, let's take a look at the column of chocolate now, right here. And that is 23 students. So that is my new denominator because I only want to concern myself with how many people prefer chocolate, 23. Of those, how many are female? Well, that's the intersection between female and chocolate, or 11. So my answer here is 11 over 23. And that would be 0.478, which rounds to about 0.48. Finally, question 5 here says, what is the probability that a student is male given that their favorite dessert is donuts or chocolate? So once again, don't harp on the formula itself for the probability of A given B. Rather, think about it logically. Here we have given that their favorite dessert is donuts or chocolate. So I know that because we have given that their favorite dessert is donuts or chocolate, we have to condense our sample to only the students that prefer donuts or chocolate, or these two columns right here. So instead of having 102 total students in our sample, we're just going to have 41 and 23. That's going to be my denominator, 41 plus 23, because 41 students prefer donuts and 23 chocolate, for a total of 41 plus 23, or 64 students. Now, what about my numerator? Well, my numerator is going to be the number of male students in that subset. So here, how many male students like donuts? Well, that is going to be 17. And how many male students like chocolate? 12. So my numerator is going to be 17 plus 12, or 29. So the answer to question 5 here is going to be 29 over 64, which when we round to the nearest hundredths place is going to be 29 over 64 in my calculator, or 0.45. So the answer to question 5 is 0.45, which is around 50%. About half of the students, give or take, that prefer donuts or chocolate are male. So that wraps up these questions on conditional probabilities. I hope that helped, and I'll catch you in the next one. Again, if it did, go ahead and like, comment, and subscribe down below. See ya.